Hello everyone. In this video, we will talk about the graphical representation of motion. To describe the motion of an object, we can use line graphs. Line graphs show dependence of one physical quantity such as distance, velocity, etc. to another quantity such as time. In this video, specifically, we will talk about the distance time graph of the motion of an object. What is actually a distance time graph? While we draw a distance time graph, we will take the distance values along one axis and the time values along the other axis. And we will get a graph by joining the points. Now let's see how to plot a distance time graph of an object moving with uniform speed and the nature of the graph. We know that when an object travels equal distances in equal intervals of time, the object moves with uniform speed. So here you see in this table, we have distance traveled in meters by an object at regular intervals of time. Okay, so here you can see when we are taking this interval of time 0 seconds to 10 seconds, so the time interval is 10 seconds and the distance traveled by the object is 5 minus 0, that is 5 meters. If you are taking any other interval of time, okay, 20, 30, so the interval of time is 10 seconds and the distance traveled is 15 minus 10, that is 5. So while you are taking any interval of time here given in this table, you can see the object travels equal distances 5 meters like that in equal intervals of time 10 second, 10 second, and if you are taking this 2, the interval of time is 50 minus 40, that is 10 seconds. Okay, the distance traveled is what? 25 meters minus 20 meters, that is again 5. So you can take any interval of time given here in this table. You can see the object travels equal distances in equal intervals of time 5 meters, 5 meters, 5 meters, then 10 seconds, 10 seconds, 10 seconds. Okay, so here the object covers equal distances in equal intervals of time. Right, so we can say that this object is moving with the uniform speed. Alright, this object is moving with the uniform speed. Okay, now let us draw the distance time graph using the given details. While we draw the distance time graph, we will take the distance values along the y-axis. You might have studied about x-axis, y-axis, etc. in mathematics. We used to take this axis as the x-axis and we used to take this axis as the y-axis, right? While we draw the distance time graph, we will take the distance values along the y-axis. So here we will take the distance values. Within brackets, we will write the units. Distance is measured in meters. So within bracket, I will write meter. It is measured along the y-axis. It is marked along the y-axis. Okay, then we will take the time values along the x-axis. So along the x-axis, we have the time values and time values. Time is actually measured in seconds. So within brackets, I am writing the unit second. Okay, so while we draw the distance time graph, we will take the distance values along the y-axis and time values are taken along the x-axis. Okay, now how can we draw the graph? You see, when it is 0 seconds, when the time is 0 seconds, the distance is also given as 0 meters. So 0, 0. Time 0 and distance 0 means this point now, origin. Okay, next you see the time when it is 10 seconds, the distance traveled by the object is what? 5 meters. So you want to take the 10 seconds right here, right? 10 seconds. Then corresponding distance value is 5 meters. So you want to join this 5 meters, this 10 second, this point. These two. So you will get a point here. Right. Similarly, you want to take the corresponding distance. The distance corresponds to 20 seconds. You will get a point here. You want to take the distance corresponding to 30 seconds. So you will get a point here. Okay. So here you see, corresponding to 10 seconds, the distance traveled is 5 meters. So by joining these two, we will get a point here. not joining, corresponding to 10 seconds, the distance traveled is 5 meters. So the corresponding point is here. Similarly, corresponding to the time 20 seconds, the distance traveled is 10 meters. So 20 seconds, 10 meters. So we will get a point here. Similarly, 30 seconds, 15 meters. So 30 seconds, 15 meters, we will get a point here. Okay, then 40 seconds, 20 meters. So 40 seconds, 20 meters, we will get a point somewhere here. Alright, then 50 seconds, 25 meters. So 50 seconds, 25 meters, we will get a point here. Alright, now we want to join all these points. Okay. So, when I joined all these 1, 2, 3, 4, 5, 6 points, I got a straight line. Okay, so this is actually the distance time graph of an object which is moving with the uniform speed. Right, and we got the nature of the graph as a straight line which is inclined to the time axis or the x-axis. Right, that is for uniform speed. The graph of distance traveled against time is a straight line which is inclined to the time axis. It makes some angle with the time axis. Okay, it is inclined to the time axis. So what is the nature of the distance time graph of an object moving with the uniform speed? It is a straight line inclined to the x-axis or inclined to the time axis. Alright, now we can use this distance time graph to determine the speed of an object. To determine the speed of an object from the distance time graph, we just want to consider a small part of this graph. So I am considering a small part of this graph. For example, I am considering this part. Okay, I am considering this part of the graph. And I am naming it as A, B. That is, by using distance time graph, we can calculate or we can determine the speed of this object. Because speed is not given here, we can determine the speed of this object by making use of this distance time graph. To determine the speed of an object from the distance time graph, we want to consider a small part of the graph. You can consider a small part of the graph here. You can consider this small part of the graph, or you can consider this small part of the graph. Okay, it is your choice. I have just considered a small part of the graph here and I have named it as AB. Okay, now we want to draw a line which is parallel to the x-axis where the time values are marked from the point A. Okay, so I'm drawing one line from the point A, then which is parallel to the time axis. So this is a line starts from this point A and it is parallel to the time axis now. This is parallel to the x-axis now. Okay, now we want to draw another line parallel to the y-axis where the distance values are marked from the point B. So I'm drawing one line starting from the point B and it must be parallel to the y-axis. Okay, so first I have drawn a line from the point A and it is parallel to the x-axis where the time values are marked. Then after that I drew a line from the point B and it is parallel to the distance axis or the y-axis where the distance values are marked. Okay, these two lines meet each other at this point now. Right, these two lines meet at this point now. So I'm just naming this point as C. Okay, now you see we are getting a triangle here, triangle ABC. Right, triangle ABC. Okay. So here we got a triangle ABC. Now to get the speed of this object from the distance time graph, we want to find out the slope of this line AB. Okay, first we have considered this part of the graph AB to find out the speed of this object from its distance time graph, we want to find out the slope of the line AB. How can you find out the slope of the line AB? Slope of the line AB is actually equal to this side divided by this side. Okay, slope of this line AB will be equal to this side, that is BC, divided by this side. This side means what? AC. Alright, so if we can find out the slope of this line AB, we will get the speed of this object from the distance time graph. Okay, now how can we find out BC and AC? Then only we will get slope, then only we will get the speed, no? How can we find out the value of BC? You see, BC, it is a side of this triangle ABC. Okay, it is a side of this triangle ABC and it is parallel to the distance axis now. Right, ABC, it is a side of this triangle ABC and it is parallel to the distance axis. Right, so we will get the value of distance while we are calculating this BC. Alright, so BC will give us the distance values. So B corresponds to what? 25 meters. C corresponds to 15 meters. So BC will be what? 25 minus 15. Okay, so this can be written as 25 minus 15 divided by AC. You see, AC, it is a side of this triangle ABC and it is parallel to the time axis. Right, AC, it is a side of this triangle ABC and it is parallel to the time axis. Okay, so AC will give you time values. C corresponds to 50 seconds, A corresponds to 30 seconds. So what will be AC? 50 minus 30. Okay, so AC is 50 minus 30. Alright, so slope is equal to 25 minus 15. What is 25 minus 15? 10. Right, divided by 50 minus 30. 20. Okay, 0, 0 cancelled. 1 by 2. 1 by 2 is actually what? 0.5. So we got the slope of this line AB as 0.5. So slope of the distance time graph is actually what? It is the speed. So here we can write speed of this object is equal to 0.5 meter per second or meter second raised to minus 1. Because distance values are measured in meters, time values are measured in seconds. Okay, so that is the object moves with a uniform speed of 0.5 meter per second throughout its motion. Alright, so we got the distance time graph of an object moving with the uniform speed. We got the nature of the graph as a straight line which is inclined to the time axis. Alright, then we have discussed about how to find out the speed of an object, any object. Okay, speed of an object from the distance time graph. That is, we just want to consider a part of this graph. You can consider a part here, you can consider this part, or you can consider this part of the graph. Okay, then we want to draw such two straight lines. One is parallel to the time axis, another one parallel to the x-axis, I mean distance axis. We will get a triangle here. You can name it like PQR. Okay, whatever you want, X, Y, Z, whatever you want. I just named it as ABC. Then to get the speed of this object, we just want to find out the slope of this graph AB. Slope of this, this part AB. Slope of this part AB, this line AB is actually equal to this side BC divided by this side AC. BC is a BC is actually a side of this triangle ABC which is parallel to the distance axis. Okay, so BC will give you distance values. B corresponds to 25, C corresponds to 15. So BC will be equal to what? 25 minus 15. Then AC will give you, AC is actually a side of this triangle ABC which is parallel, this AC is parallel to the time axis. So AC will give you time values. C corresponds to 50, A corresponds to 30. So AC will be what? 50 minus 30. Okay, 25 minus 15, 10. Then 50 minus 30, 20. 0, 0 cancel. 1 by 2 is 0.5. So we got the slope of this line AB as 0.5. That slope is actually what? The speed of the object. So speed of the object is equal to 0.5 meter per second. That means the object moves with a speed of 0.5 meter per second throughout its motion. Alright, I hope you understood this. Now, let us see the nature of the distance-time graph for an object moving with a non-uniform speed. That is an accelerated motion. So, if an object covers unequal distances in equal intervals of time, we can say that that object is moving with a non-uniform speed. So, a table of time values and distance values are given here. The time is measured in seconds and distance is measured in meters. So, you see in this interval of time, that is 2 seconds, 2 minus 0, 2. The distance travelled by the object is 1 minus 0, 1 meters. When you are taking this interval of time, 4 minus 2 again 2 seconds, but the distance travelled by the object is 4 minus 1, 3 meters. Okay, now when you are considering this interval of time, the time interval is 2 seconds, 6 minus 4, 2. But the distance travelled by the object is what? 9 minus 4, that is 5. Okay, you can take any other interval of time here. That is, here I just want to say that this object, an object that can be a car, that can be a bike, or that can be anything else. This particular object that covers unequal distances, 1, 3, 5 like that, no. Unequal distances in equal intervals of time, 2 seconds, 2 seconds, 2 seconds like that. So here the object covers unequal distances in equal intervals of time. So we can say that that object is moving with non-uniform speed. Okay, now to draw the distance time graph, we just want to take the time values along the x-axis and distance values along the y-axis. Don't forget to write the units within brackets. Now you just want to mark the points here 2, 4, 6, 8, 10 like that. Here I have marked 0, 5, 10, 15 like that. Now you just want to get the points corresponding to the values given here and you want to draw, you want to just join all those points. So let's see how to draw it. I just marked the points here. You see when it is 0 seconds, the distance travelled is 0 meters. So 0, 0, that point will be here at the origin. Next, when the time is 2 seconds, the corresponding distance travelled is 1 meters. So 2 seconds, 1 meter will be somewhere here. So you will get a point somewhere here. Then 4 seconds, 4 meters. So 4 seconds, 4 meters will be somewhere here. So corresponding to that you will get a point here. Similarly 6 seconds, 9 meters. So 6 seconds times 6, then distance 9. So 9 will be somewhere here. You will get a corresponding point here. So while you are while you are marking all these values here, you will get 1, 2, 3, 4, 5, 6, 7 points here. Okay, now to get the graph, what we just want to do, we just want to join all these points. Okay, so I'm joining all these points, you see. Okay, so here I am getting the shape of the graph like this. That is, it is just like a curve. Okay, so the distance time graph, it is not a straight line. That is the important thing. It is not a straight line. While we have discussed about the distance time graph of an object which is moving with the uniform speed, we got a straight line which was inclined to the time axis. But you see here the shape of the graph, it is not a straight line. The object is moving with the non-uniform speed. And the graph, the nature of the shape of the graph, it is just like a curve of any shape. Okay, it can be a curve, it can be a zigzag line like that. Okay, that means the distance time graph of an object moving with the non-uniform speed is a curve of any shape. It can be a curve like this, it can be a curve like this. Okay, it is a curve of any shape. Alright. So in this video, we have actually discussed about the distance time graph of an object moving with the uniform speed, then for an object moving with non-uniform speed. And we have seen that for an object moving with uniform speed, the graph is a straight line inclined to the time axis. And for an object moving with non-uniform speed, it will be a curve of any shape. Okay, it can be a curve like this. It can be a path like this. Okay, it can be a curve of any shape. Alright, then we have determined the speed of an object from the distance time graph by finding out the slope of that graph. I hope you all understood the concepts. Thank you.